So today we are going to be answering this question regarding the bank discount and rational discount. It says determine the bank discount and rational discount on May 23rd of 2023 of a bill of exchange with a value of $10,000 maturing on September 3rd, 2023 at a simple annual interest rate of 8%. All right, so first thing I'm going to do is I'm going to write down the things we know. So, first of all, we know that the nominal value here, NV for nominal value, is $10,000. We also know that the interest rate and the discount rate are both 8%. So, I'm just going to put that in decimal form 0.08. And then the next thing that we don't know exactly, but we can figure out pretty easily, is the number of days. So n is going to, in this case, be our number of days. So our number of days is going to be, let's see here. So we have May 23rd till September 3rd of the same year. So in May, there are, let's see, there are 31 days in May. And we have this from May 23rd to the end of May. So the 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, and 31st. So that's 9 days for May. Then all the days of June. All the days of June would be 30 days. So 30 days for June. Then July, all of July, which is 31 days. Same with August. August is also 31 days. And then September, we're just doing the first 3 days. So 3 days, 3 days for September. Like that. Okay, great. Now we just need to add all of those numbers up to figure out what the number of days is. And then since n is typically annual, we're going to divide by 360 as well in our next step. All right, so 30 plus 31 plus 31 plus 3 plus 9, that gives us 104 days. And just to simplify it, we usually tend to divide by 360 rather than dividing by 365, just to, have the standard banker's year. So we're going to say n is 104 over 360 like that. All right, so now how do we determine the bank discount? Okay, so the bank discount is going to be, we're going to write it like this, DB for discount of the bank discount, is equal to the nominal value times D times N. In this case, that's going to be $10,000 times 0.08 times the value we just found for N, so 104 over 360. And let's grab a calculator. Let's figure out what that is. 104 over 360 times 0.08 times 10,000 is $231.11. So that is the answer for the bank discount there. Next, let's calculate the present value. So the present value is going to be the nominal value minus the discount. And that is going to be $10,000 minus $231.11. And that gives us that the present value is $9,768.89. So that's the answer for that part. Next, we're going to find the rational discount. So basically, what we first need to do is we need to say, well, we know that the present value for the rational discount is going to be, present value is going to be equal to the future value over 1 plus I times n. And then the future value is $10,000, right? That's the same as nominal value in this situation. So $10,000 over 1 plus I times n. So 1 plus, I think it was 8%. Yep, 8% times n, which was 104 over 360. And let's see what that is going to equal to. And it should be somewhat similar to the present value we found earlier, but probably not the same amount, since now we're doing rational discount instead of bank discount. So 104 over 360 times 0.08 plus 1, so 1.023 approximately, and then 10,000 divided by 1.023. That gives us about $9,774.11. So a slightly different amount than what we calculated before, but pretty similar. Okay, so that's the present value. Now we need to figure out the rational discount, denoted by DR, rational discount. That's going to be this present value we found here, times I times N. And that is going to be $9,774.11 times the interest rate of 8% times 104 over 360. All right, so that is going to be, let's see, times 0.08 times 104 over 360. Okay, so that is going to be $225.19. So there we go.